You've probably used 4 or 5 Java-powered systems today without knowing it. Your banking app, a delivery tracker, maybe a big data dashboard behind the scenes. Java isn't one narrow tool. It's a workhorse spread across some very different corners of technology. Let's look at where it actually shows up. First, and still the biggest, enterprise backend systems. One important nuance here. Banks' core transaction ledgers often still run on decades-old mainframes in COBOL that hasn't gone away. But almost everything built around that core increasingly runs on Java, online and mobile banking backends. Fraud detection systems and the AP is that connect legacy mainframes to modern digital services. HSBC and Citibank, for example, use Java for exactly this kind of work. Add insurers and large retailers running their business logic on frameworks like Spring Boot and Jakarta EE. Think ERP and CRM platforms, and this is still Java's biggest single domain today. Second, big data. Some of the most important tools in this space are literally written in Java. Hadoop, the framework that popularized distributed data processing, has its core components, HDFS and Yarn, built in Java. Kafka, the standard for real-time event streaming, is written in Java and Scala. Even Spark, though it offers AP is in other languages, runs on the Java virtual machine at its core. If your data pipeline touches any of these tools, it's touching Java. Third, Android. For its first decade, Java was the primary language for building Android apps. That's changed. In 2019, Google made Kotlin its officially preferred language for new Android development. And most new apps are built in Kotlin today. But Java hasn't disappeared. It still underpins a huge amount of existing Android code, remains fully interoperable with Kotlin, and is still commonly used to maintain and extend legacy apps. Fourth, embedded systems and the Internet of Things. This is actually where Java began. It was originally designed for interactive television and consumer devices before the web took off. That same portability, code that runs unmodified on very different hardware, still makes Java a practical choice for IoT devices, smart appliances, and industrial control systems today. Fifth, desktop applications. Java can build full desktop GUIs directly using toolkits like Swing, AWT, and Java FX. IntelliJ IDEA is itself a Java desktop application, running on the JVM like everything else on this list. Sixth, gaming. The best-selling video game of all time, Minecraft, runs on Java. That's literally why the original PC version is still called Minecraft Java Edition. Game engines like JMonkey Engine extend this further, giving Java a real, if niche, presence in both 2D and 3D game development. Seventh, scientific computing. Java's precision, portability, and strong math libraries make it a solid choice for simulations and numerical analysis. MATLAB, one of the most widely used scientific computing platforms, uses Java under the hood for both its front end and parts of its back end. And eighth, AI and machine learning with a caveat. Python still dominates experimentation and model training. But when it's time to deploy a model into a reliable, large-scale production system, teams often turn to Java, using libraries like Deep Learning 4J precisely because of the reliability strengths we covered in Video 1. So Java isn't defined by one use case, it's defined by showing up wherever reliability, scale, or sheer staying power matter. From enterprise backends and big data pipelines to your desktop IDE, the world's best-selling game, and production AI systems, Java is quietly everywhere. It's the silent force behind the systems we use every single day.